Hi everyone, welcome back to the second video in our series, Generative AI Made Easy. In this series, we are exploring how to simplify generative AI concepts using social media content automation as a practical example, as it covers a wide range of generative AI applications. In the last video, we laid the groundwork with an introduction to generative AI to get you up to speed with the basics. Today, we are moving forward by setting up the environment to self-host workflow automation engine. And as a bonus, we will also walk through setting up HTTPS certificates for those of you who are ready to take their setup to the next level. Let's get started. All right, so why use a workflow automation engine in the first place? Well, multiple reasons. First, it offloads all of the code complexity, whether that's API calls, error handling, retries. It's all managed by the workflow engine so that we can focus on our application logic. Second, it is visual and low code, which means it's beginner friendly, it's easier to maintain, and easier to extend. And lastly, we are not starting from scratch. We are building on top of the hundreds of available nodes, so then we can just plug and play and add the logic that we need. Now, for the tool of choice, I tested many, and there was two that stood out. First is n8n. It's a highly extensible and customizable. It's been around for a while now, since I believe 2019, and that is why it's a very well set up, very matured product. It has AI in the heart of its concepts. So things like the AI agents, we can already leverage what they have currently without writing any code. It is a very well documented product, and it has 400 plus integrations, very AI focused, but not only. It is a very stable, very extensible solution. The second solution that I've tested is Active Pieces. It is a relatively newer solution. Similar to n8n, it has so many integrations. It's also like so AI focused, and it's well documented product. I think it's just like lacks the flexibility that n8n offers at this point. And it is, I would say, a very promising solution to keep an eye on. Now, to self-host n8n, similar to many of the tools we're going to need for the rest of this series, we will need to deploy it as a container. And in order to do that, first we need to make sure that we have the NVIDIA drivers set up. We will not actually need them for n8n itself, but we will gonna need it later on when we run our LLMs locally or when we generate images and videos. The second thing is to deploy Docker Desktop. We are running on Windows, and for that the best and most simple way is to install Docker Desktop. And then we will install some development tools. It's just a way of managing the containers. Different people might have different ways of managing containers. I will explain the way I prefer to do it. It doesn't have to be like this. Then we will be able to set up and self-host n8n, and we will see the steps to do that. And then finally, and for the overachievers, we will set up a reverse proxy and HTTPS certificates to have more secure, more user-friendly names instead of dealing with IPs and ports. For the NVIDIA drivers, we just need to visit the NVIDIA website. We will need to choose the card model. In my case, I have 3090. I'm running on Windows 11, so I click Find. We'll see that there are two options, the Game Ready driver and the Studio driver. Both should work. This is more focused for gamers. This is more for content creators. But whatever you choose, it should work fine. Next, we will have to install Docker Desktop. For that, we will visit docker.com and we have to download Docker Desktop. It should be a fairly simple setup as well. So next. And by doing so, we should have an empty running Docker Desktop. As you can see, we don't have any containers yet. But yeah, while we are here, there is an important step that we need to do. We need to go to Settings, Resources, and then WSL integration. Just make sure that this option is taken in. After installing the NVIDIA drivers and Docker Desktop, we will install Visual Studio Code or any similar IDE. If you prefer Windsurf or Cursor, then that's fine. In conjunction with the Docker extension, we'll be able to manage directly on the IDE, the containers and the Docker Compose. So for that, we will just go to the Visual Studio Code. We download it, we install it. It should be a fairly simple setup. Now, the first thing we need to do is by installing an extension. It was called Docker, now it's called Container Tools. It's an official extension for Microsoft, and it should allow us to manage containers directly from the IDE itself. Let's create a folder. If you'd like to clone a repository from GitHub in order to back up your Docker Compose, I actually suggest that. I'm doing that in my setup. But for today's video, we'll just keep it simple. We'll open a folder, putting everything under C home stack. And this is where we will be creating our Docker Compose and configuration files. Next, we will create a Docker network. It's not a mandatory step. It's just like a way of organizing our code. I prefer to do it like this. So I will create a network and I will call it home stack network. You can call it whatever you would like to. And we will just open a terminal. And we will type the command. And that is our network created. Now to actually configuring n8n. So for that, we will create a Docker Compose. Docker Compose is a better way of managing containers rather than creating individual containers using Docker run. We'll just put all of them into a Docker Compose file, and then we can manage all of them at once. So for that, we'll have a list of services. For now, we'll create n8n as a container, as a service. It is using the official n8n image. It's called n8n. It can be whatever. And then for the environment variables, it's very important to set up this properly. The first thing is the domain name. If you don't have a domain name, you just put the IP address here, and we will see later on we'll create a custom domain, but it's not mandatory to run n8n. You specify here the port. The next thing is the n8n protocol. If you are to follow the video till the end, then yes, we will use HTTPS. But if you would like to skip that part of setting up HTTPS certificates, then you can just set up HTTP here. And then for the node environment, leave it to production, don't worry about it. And then for the webhook URL, it has to be the protocol. In our case, it's either HTTP or HTTPS. And then the domain name, if you are using a domain name, or the IP address of your local Windows machine. The time zone, and then some tuning settings. First one is to increase the payload from default 60 meg to, in this case, I'm setting it to 250 megabyte. And the reason here is because we are dealing with large files like the video later on, 60 megabyte, it's not going to be enough. Similar to the setting the binary data mode to file system, that's also like to bypass issues with uploading large files, and we will be dealing with large files. This one is to enable the execution of user-provided JavaScript code, and also like to allow the import of libraries or models within the JavaScript. And then the last one is basically to allow the execution or installation of community nodes. For the ports, we can leave it as default. And then for the volumes, this is like the data configuration of n8n. So we are setting it up in a volume so we don't lose it if we delete the container. And then the second volume, that's going to be our working directory to integrate n8n with the image generation and video generation. So it's very important. For now, just we can create it. If you miss it, no worries, we can always change it later on. And then this is finally where we specify the network we just created. So all containers that are created within this Docker Compose are going to be attached to this default external network. So let's copy this and head back to Visual Studio Code. We'll create a new file. We'll call it docker compose.yaml, and we'll paste the n8n configuration. We will customize it. So in this case, as we are not using yet the domain name, we'll set up the local IP address. You will know it, of course, by running ipconfig or by looking into the network configuration of your host. And we will put it for now as an HTTP. The second part of the video, if you are interested, we change that to HTTPS with a domain name. But for now, we will just keep it simple. We don't really need to worry about the rest. Now, the reason why we are using this containers extension is we can manage the Docker Compose files or containers directly from Visual Studio Code. So we can do a compose up, or we can run the individual containers here We will see later on that we can restart, we can manage individual containers, and we can connect to them. As we see, the Docker Compose have created the 2 folders we have specified. And if we see here, the container was created. And we check here, we see that the container is running. And we can see that it is attached to our home stack network. And we can see that it's exposing port 5678. So let's click on that. And voila, we have n8n up and running. First thing we need to do is to set up an account. And we need to provide a valid email address because we will receive an activation key later on. So for that, I will set my email address. Then click Next. And click Get Started. You see here, it says get paid features for free forever. This is the community edition. So that's why we need like the valid email address. We click Send me a free license key. We need to go to our email, copy the activation key, and then go to the settings and enter the activation key. And voila, you have now n8n running on your machine. You don't really need to pay for it. Now, for the overachievers, for the people who would like to go the extra step, instead of having like HTTP and dealing with ports, we can set up a customized domain name and certificates for free. If this is not your cup of tea, don't worry, it's not mandatory. You can stop here. This is already enough for us to continue with the rest of the video series later on. So in order to have a customizable domain name and certificates, what we'll need to do is to set up a reverse proxy and a domain name. There are multiple open source options out there. The tool of choice from my side is Nginx Proxy Manager. That's because it has like a very nice, simple GUI. The second tool we'll use is DuckDNS. It's a free DNS domain name provider. We can have our own custom domain name. So let's go there. You can sign in using Twitter, GitHub, Reddit. I will be using Google. And after signing in, we can now create our first domain name. In my case, I will set up my home stack as a domain name, and I will try to see, and it's available. So now we have a domain name that is myhomestack.duckdns.org, free forever for us. Usually we need to put the public IP here. In our case, we will just access the domain name from within our network. At least that's my use case. And for that, we don't really need the public IP. What we can do is just set it up to point to our private IP. So we click Update IP. We see now we have our domain name. Let's test it. Let's open a terminal and let's ping it. And voila, as we can see, it's reachable from within our network. Because it's private IP, if we try to reach it out from outside of our home network, then of course it will not work. And that's fine because I don't want to expose my internal network to the internet. So it should be even more secure. Next, we will install Nginx Proxy Manager as a container, similar to what we did with n8n. It's a very simple configuration. All what we need is the official image for Nginx Proxy Manager. We will name it npm. We need to expose these ports through our home router. You can always customize these ports if you need to, but in my case, I'm using this just for Nginx Proxy Manager. The rest of this setup is simple. We'll have 2 volumes. One is to protect the configuration of Nginx Proxy Manager itself, all of the proxy hosts that we'll be creating. And the second one is for the Let's Encrypt to store the SSL certificates. Let's copy this. Then we run the service. As you can see, the container is created. You can double check that here. And if we try to log in using port 81, there you go. That's Nginx Proxy Manager. The first time we try to log in, it's going to ask us for login and password. By default, it's admin@example.com. And for the password, it's change me. As soon as we log in, it will ask us to change those. So for the full name, I will use home stack. And the email address, It will then ask us to change the password from change me to a new password. And voila, we now have access to Nginx Proxy Manager. The next step is to create the SSL certificate. Add a new SSL certificate. It will ask us about the domain name. That's the one that we created recently. So we will just copy that. And don't forget to add wildcard certificate. This is very important. So then if you would like to, and we will, create domain names like n8n.myhomestack.dns.org, that's going to be accepted, but also the certificate's going to be valid, not only for the domain name, but any subdomain name. Now we click on the use DNS challenge. We choose DuckDNS as our provider. And then we are asked about token. We'll go back to DuckDNS, and the token is here, so we copy it and we put it here. We agree to the term of services of Let's Encrypt, and we hit save. Now, if our configuration is correct, especially the home router config, then this should take about 1 to 2 minutes, and then we will have our certificates created for us, publicly signed by Let's Encrypt. If you got an error like this, don't worry, it happens. All what we need to do is just increase the timeout. And voila, we got our certificate. As you can see, it was created today. It is valid until 90 days from now. And the inactive status means that it is not in use yet. Let's go to hosts, proxy hosts. And here we can create the custom domain names and subdomains for our containers. Before doing that, if we go back to the n8n, you remember we used the IP address. That's because we didn't have a domain. It's worth noting that it's completely fine if you would like to run with the IP. But in our case, now that we have the domain name, we'll just copy it. Head back here, paste the domain, and also update the IP here. And then as we have also created an HTTPS certificate, let's also change now that we would like to use HTTPS as well. It's worth noting that we'll not be needing exposing any ports anymore. So for now, I will just comment it. And let's update the n8n configuration either by recreating this service or by restarting it from here. I will just recreate it from here. So we don't really need to specify anything else more than the name of the container and the internal port of the container. This will expose it to the host network. We don't really need that anymore. We just need to expose the ports of npm or Nginx Proxy Manager. And then npm will communicate with n8n using the internal Docker network, and npm can reach n8n on its port. Let's try that. Let's go back to Nginx Proxy Manager, add a host. So for the domain name, it's going to be n8n.homestack.dns.org. And then for the forward host name IP, we can just put n8n. And then for the port, it's the 5678. We will enable WebSockets because n8n uses WebSockets. If you are not sure, just enable it. Then we'll block common exploits. It's best practice. And then head to the SSL certificate. We will choose the wildcard certificate we just created. We will force SSL. So whenever we connect using HTTP instead of HTTPS, it will redirect us to HTTPS. And then you can enable HTTP to support. You can also enable anything else. I'm fine with this configuration. And we can test it. And voila, we have n8n running as a domain name using a valid certificate. Now let's do the same thing for npm itself. So let's add a new proxy host. Let's call it this time npm.myhomestack.duckdns.org. Let's add npm as the host. It's running on port 81, if you remember. I'm not sure if it requires WebSockets or not, but I will just enable it. I will also enable block common exploits, add my certificate, and then enable forcing HTTPS. And if we connect to it, npm itself is now running using our domain or custom domain and using the created certificate. Now, in this example, we showed how to use Duck DNS as a free DNS provider. It doesn't, of course, have to be Duck DNS. We check the SSL certificates. We'll see that Nginx Proxy Manager supports a wide range of providers. For the next video, we'll start using n8n that we just self-hosted to build the first part of the pipeline of this video generation, to run local LLMs. And as a bonus, we will have our first AI agent to do more than just story generation. So stay tuned for the next video. Until then, I thank you for joining me and can't wait for our next video. Thanks a million.